Okay, welcome to Noisebridge. This is the Noisebridge Python class. This class meets every Monday at 7 p.m. at Noisebridge in San Francisco. Today's class, we're going to be covering algorithms, and not really in the computer science sense of like sorting and graphs and trees and all that stuff. More just as like an algorithm is just the way you solve a problem. So this class is kind of marks a turning point in this lesson, marks kind of a turning point in this class where we go from like, this is what a function is, this is what a dictionary is, and we start trying to actually solve problems and like write programs. So yeah. So here's my definition of algorithm. An algorithm is a process or sequence of steps used to perform a task or complete a computation. Okay. We'll start with basic everyday algorithms, and I don't think we're even going to talk about any computer science-y algorithms, but whatever. All right, so we have a list of numbers. How do we find the largest number in this list? So I'm not writing any code. I'm going to talk about the algorithm. The algorithm that I'm going to use is take the first number from the list and assume it's the biggest. Then we compare it to the next number. If the next number is bigger, consider that the biggest. And we continue in this way, comparing our current biggest number to the next number in the list each time until we reach the end of the list. So we walk or iterate through the list, and we have the biggest number candidate, and we compare that to the next number. So we start, the first number is probably the biggest, right? Compare it to the next number. Oh wait, that number's bigger. Compare it to the next number. No, it's still the biggest. Compare it to the next number. And we go all the way to the end of the list. And at the end of it, we'll have the biggest number. So how do we write code for this algorithm in Python? This isn't marked as an exercise necessarily, but it might as well be, right? I think like I was predicting that like we could just talk through it a little bit, but maybe if everyone has the notebook open, we can try to, if you run this code first up here, you'll have the number list. Use like print biggest number list. And if we do that, it'll just print none for now, because a function that doesn't return anything returns none. So yeah, everyone, to your Python notebooks, try to implement the biggest number algorithm. Think about all the steps. Take the first number in the list. How do you do that? Compare it to the next number in the list, et cetera, et cetera. So right off the bat, there's an exercise, and we'll take a couple minutes to let that stew. I'll come around, look a little bit. I don't think we're going to spend all the time trying to get this like completely right for everyone. We're just going to like take a crack at it, and then I'll show the answer. Okay. So let's bring it back together. I'm going to talk through this algorithm. I want to turn off IntelliSense for a second. What was it? Oh, Copilot. Turn off. Does anyone know how to turn off a toggle? There we go. All right. Okay, so again, we should look at our algorithm, right? Take the first number from the list. So what's the first number of number list? It's number list 0. So if we just print it, but if we just sit it on a line by itself like that, it's an expression, it's a statement, but it doesn't do anything. So we want to actually capture this value. We want to take that number. So we say biggest number equals number list 0, right? Now, we're going to compare it to the next number in the list. And then we're going to compare it to the next number of the list and the next number of the list. So we want to iterate over the list, right? So we want to use a for loop to go through the list item by item. So for n in number list, and there's an optimization here. I'll get back to it in a second. So now we're looking at every number in the list, and we're saying like, what's this thing? If the next number is bigger, consider that the biggest. So if n, which is the next number, is bigger than biggest number, now we consider that the biggest. So we assign n to biggest number. And that now it says continue in this way, comparing to the next number, and we notice that we are continuing because we're going through the list with the for loop. So we go through every number in the list, we compare that number to the biggest number, and until we reach the end of the list. We don't have to do anything to reach the end of the list, right? Like the for loop just gets to the end of the list and finishes. And then we can return biggest number. If I run this, it says 42. Is that the biggest number? Yes. And the only optimization here is that we can say, like, technically the algorithm says compare it to the next number in the list. If we iterate this way, the first comparison is going to be against itself, right? Because this for n in number list starts at the beginning of the list, but we already took the first item in the list, right? So we can use slice notation here to say go from item at index 1, which is the second number, to the end. If I run it again, it's still 42. Any questions?
You mind explaining the position of here right now, the 1, 2 dots, parentheses, 2 dots for creation of the second number on the list?
This part?
Yeah.
Yeah, so this is called slice notation in Python. Where is it? Here we go. Okay. So I have this. Oh, I have to run some of these first. Okay, so I have this tuple, which is basically a list. Oh, it is a list. Okay, so I have this list. It works the same for tuples. And it's some data about the United States. It says the population, the capital is Washington, D.C., the biggest city is New York City, and here's some other cities, which includes New York City, but that doesn't matter. Okay, here's slice notation. So if I say United States bracket 0, that's the first item, right? Because we're indexed at 0, we get that. If I say 3, that's the fourth item at index 3, no problem. If I say -1, what's that? Last item, great. Now here's where we get this colon stuff. So if I say 1:3, it starts at index 1, and it goes up to but not including index 3. So it's index 1 and 2 only. And so the way you remember that is that 3 minus 1 is 2. You get 2 items, right? And then let's run it now, as we're starting to get to the confusing ones. So then :-1 means if I don't put anything in the front, it means from the beginning. And then 2-1 means, just like before, it doesn't take the item at that index. So it's everything but the last item. From 0, which was omitted, this is the same as putting a 0 here, right? To -1, which is the last item. So everything between the beginning of the list up until the last item, but not including it. Cool. And then we can see that down here, which is like the population, Washington, D.C., New York City, but not, yeah. All of these operations return lists too, except like if you have a colon, it's going to return a list. If you don't have a colon, it returns a single item. And then here, 2:nothing is just from the second item to the end of the list, including the end of the list this time. That's like the 90-second version of slice notation. Yeah.
So those square brackets, especially on that last one, so like we're including, you see how there's a square bracket in front of New York City and a square bracket again?
Yes.
And that's a separate like
Right.
item.
Item,
It's returned.
the item at index 3 of this list is a list.
Yeah.
So like here's like the item at index 0, item at index 1, item at index 2, and the item at index 3 is a list. So what we could do, what if we wanted to get the second item out of that list? What if we wanted to get Los Angeles? How do we do it?
We have stack parentheses.
Yeah, yeah, brackets, but yeah. So we say like, how do we get that list itself?
So we do a 3
Yep.
colon.
No, we don't want colon because that's going to give us a range.
Okay.
We want to take this item, which is a list, right? It's this list. And then now we want the second item of that list. So how do we get the second item of that list? This is that list. Yes, exactly. Bracket, but not parentheses. But whatever, yeah. And that's Los Angeles right there. Cool? So I see, like Paul, you were having trouble with the brackets, right? But like, it's kind of like the brackets are almost like you keep saying parentheses. It's kind of like works the same because it's almost like I'm calling United States and getting the third item. Except I use a bracket because I'm not calling it. It's not a function. It's a list. So I say bracket 3, give me item 3. And then from that, give me item 1. And this can just go on, like forever as long as you have all the nested lists there, But if you don't have the nested list there, it's just going to be an index error.
I was just gonna say, what would happen?
Oh, well, at first it gives me n.
Letters?
Yeah, because the strings themselves are lists of characters, basically. So you can take like, I can take like happy birthday, and I go 0, 1, 2, 3, 4, 5, 6. There should be capital B. But if I keep going after that, capital B is not a list. So if I do like 3 here, that's an index error. String index out of range. But you can do, if I do 0, it's a capital B again. If I do 0, it's a capital B again. So you can just kind of go forever on that. Because they're each returning a string of one item, and I'm asking for the first item. That's just kind of nuts. Don't worry about that.
I was curious, just because like you were saying it would loop through the things, and I was like, I was thinking of something else where like you could get the next item in data. You know what I mean? Like if it's storing a string and then you put like -1, you could access like the memory before.
Yeah, it's nothing like that.
Yeah, it's not, yeah. That's
-1 just means the last item of the list.
I was like, yeah, so -1. I thought.
You're not going backwards. You're kind of going backwards because you're starting at the end and going backwards by 1. Whereas -2 would be the second to last item. -3 would be the third to last item. So you are kind of going backwards. Yeah.
I thought it would be something like a nefarious SQL injection.
No, it's not like that. Any other questions on the biggest number algorithm or code? Yeah, go ahead.
A dumb question. I did this earlier, so I can't remember how to do it, but I did a definition of get biggest parentheses numbers. How does that refer to something called number list?
Yeah, that's a good question. So basically, if I change the name of this, right, get biggest number, and I say numbers, I just change this everywhere, right? Numbers, right? And now I change the name here, get biggest number. All right, so I still get 42. So what's happening is number list is what was defined up here as this variable, right? I'm passing that to my get biggest number function because this is def get biggest number, so it's a function. It takes a parameter called numbers, and now whatever I pass to it is now stored in that as like kind of a local variable. This is kind of what we talked about. Hold on, let me get out of there. Just go. No, I can't search in here.
You have to go through it before you actually.
Oh, it's in this one. So this is what we talked about in lesson 4 the last time. We talked about function scope.
So it goes through that, and then when it does the print is when it assigns
So this returns the biggest number. So if I did like my big equals, so this doesn't print anything. If I do print my big, because get biggest number calls the function and then it returns biggest number, which then gets assigned to my big, and then I print it. So the flow here is like Python sees this line. It says, okay, there's a number list. Yep, that exists. I'm going to call this function. Then it goes up here. It runs through this code. This says return biggest number. And that gets returned here. So now it's 42 here. Right? Because get biggest number returned 42. And then my big now equals 42. So what if I did what would it print? This is a question for Genie only. 84, exactly. Cool, so you got it.
I was just trying to figure out how number list, the list got.
Yeah, so technically, I was lazy and I was using number list in both places as the variable holding our data and also as the parameter to the function. But I don't know if I covered this when I talked about like function scope here, but like there's something called shadowing where if there's a variable in a function, that takes precedence over a variable defined like somewhere else in the world. So if I called this number list again, right, that's fine because this get biggest number function doesn't care about variables outside of itself, except for like global variables. So this number list, when I use it inside here, it's not the one defined up here. It's its like own thing also named number list. And Python says, oh, well, it was defined in the function, so we're going to use that one. So when I use this here, like number list 1:, it knows to use the one defined in the function as a parameter. So it's like if I had like def say hello name. Hello name. And then if I do like name equals, or like all right, so hello Travis, goodbye Travis, right? But if I do like here, if I do like name equals Mateo, I do like name equals Claudia. Did I spell Claudia right? All right, whatever. So it says, hello, Mateo, goodbye, Claudia, because name is Travis here, but that doesn't matter to these functions because here, name is whatever got passed in to the function. So if I change it, then it prints out what I changed it to. But that doesn't affect, if I do, I can still print. If I print name here, it's still Travis.
Local.
It's like a local scope in the functions, yeah. Yeah.
Is it opposite of local public for Python?
There's no public, private, or anything in Python. No, it doesn't exist. I'll leave it. Well, I'm going to move it. Okay, back to algorithms. All right. Oh, and then this is supposed to be biggest number. Biggest number. And I have some tests here, and they both pass. Remember, assert will check if this is true, and it'll throw an exception if it's not. Okay, how do we count the number of occurrences of each letter, number, and punctuation in a string? And this is no longer true. So here we want to say like there's one H, or there's one capital H, there's two lowercase h's, there's like one capital I, there's one apostrophe, there's one question mark, etc., right? So you don't have to come up with this off the top of your head. I'm about to give you the algorithm. And the point of this is that like if someone gives you an algorithm, if you know how to code in Python, you should be able to code that algorithm in Python. Because the algorithm is the hard part. That's like, how do I even do this? What are the steps? Like how do I find a prime number? What does that mean? And like the algorithm tells you, and you just have to write the code. So create an empty dict. Here's the steps. We create an empty dict that will hold the mapping between character and number of occurrences. So it shows it here, like H1, E3, blah, blah, blah. Now we iterate over each character in the list. Iterate, what does that mean? Probably a for loop, right? For each character in the list, and this is what we were just talking about, strings are lists of characters basically, right? If there's an entry in the dict for the character, increment the entry by 1. Otherwise, create an entry in the dictionary for the character and set it to 1. And if people know enough advanced Python, you know that there's something called default dict that we could be using instead, but we're not going to use it. We're going to use this algorithm because it's more basic and we don't have to explain default dict. Okay, so how will we write this algorithm in Python? Take a few minutes and I'll come around. So really think about, instead of like, what code am I going to write? Think about like, how do I follow step 1? Create an empty dict. Like, what does that mean? How am I going to do that in my code? Like, just each step, one by one, follow those steps. I'll give you a few minutes, and then I'll come around and check on everybody, okay? Any questions before we start the exercise? No. Okay, great. I'm not sure we covered this, so I will give a hint. If we have a dictionary, I'll leave it off. And we want to check if an item is in the dictionary. We use the in keyword. So we say print apple in fruit prices. Print kiwi in fruit prices. So like, is apple in fruit prices? It is. True. Is kiwi in fruit prices? It's not. False. Okay? So like in step 2, substep 1, when it says, is there an entry in the dict for the character? This is what you're going to use the in operator for that. And the other hint is that, we already saw this, but for C in happy birthday, print so we can just iterate over a string like that. So just a few more things, refreshers on dictionaries. So a few more refreshers on dictionaries. If we have a dictionary and we want to get the value at a certain key, we slice. And if we want to create a new key in a dictionary, this is for you, Jeannie. If you want to create a new key in a dictionary, you use the bracket notation for the key that doesn't exist. And if I print fruit prices, so when I started, the dictionary had apple and banana. Apple is the key, 129 is the value, the whole thing is the entry. I printed out apple and banana. Is apple in fruit prices? Yes. What's the price of apple? So when I say fruit prices bracket apple, I'm saying what is the value for the key apple? Now, and that's $1.29. Now I say, is kiwi in fruit prices? False, it isn't. But then when I assign it like this, I'm saying, in the fruit prices dictionary, set the key kiwi equal to the value 339, whether or not it exists. And I print it again, and now it has kiwi in it. Does that make sense? So if we look at, so when we talk about the answer to this problem, so we say like answer equals empty dictionary. Let me clear this. And I want to collapse it. Oh well. So create an empty dictionary. We did answer equals empty dictionary. Okay, great. Iterate over each character in the list. All right, for char in string. If there is an entry in the dict, so we say we use this in operator that I was talking about, and it's confusing because it is the same word as like for char in string, but it's just used differently. So if char in answer, what do we do? Increment the entry by 1. So to increment the entry by 1, it's the same thing as this kiwi thing up here, right? I say answer char, that's the entry for that character, and I increment it by 1, plus equals 1. Otherwise, notice that I don't need to do like else if, char not in answer. I don't need to do that, right? Why not? There's only, yep, it's one or the other, right? Was it in there? Nope. So then I know it's not, right? I don't need to test for that. And then now I want to, what does it say? Create an entry in the dictionary for the character and set it to 1. So an entry for the dictionary for the character, that's this. That's the entry. Here we added 1 to it, but now this time I want to set it to 1. So I set it to 1. Then I return answer, run that, and now we run the test. Did I pass? Green check mark here means you passed. If I messed it up and instead did like 0 here, then when I ran this, I would get an assertion error, and it's not true. So I put it back, I'll run it again, and we're good. Okay, so, what's that? Oh yeah. I'm gonna start, there's an answers thing next to this. Yeah. Oh god, that candle thing is still in there. Okay. There's an answers. I'm starting to, as I go back through these, making an answer key for all the exercises in each lesson, because not only does that help people who are studying on their own, it also helps me, so I don't have to type out all the code every time. I just copy it in and just point to it. So, and it keeps me from looking foolish if I mess up the answer, Like, here's the prepared answer that we cooked earlier. All right, so what do I say here? The important thing to take away from these exercises is that an algorithm is different than the code that implements it. You have the algorithm, which is like the abstract mathematical set of steps to control the universe, whatever. Then you have the code, which is like how you tell the computer to calculate the thing. Algorithm, code, different things. The code implements the algorithm. That's the language we use. The code implements the algorithm. But there are possibly many ways of implementing the same algorithm. like if you implement an algorithm in different programming languages, right? Like it's the same algorithm, you're sorting a list, you're finding the number of occurrences, you're making an HTTP request, whatever it is, but you have different programming languages. Obviously, it's different code, right? So, but the algorithm is the same. So now here's another way of thinking of algorithms. So sometimes the output of one algorithm can be used as the input to another algorithm. So we have this concept of an isogram, which is a word with no repeating letters or numbers, whether in a row or not. So for example, I should have examples here for this. So like tower is an isogram, while door and enter are not. So think about this. How do we use our count occurrences method that we wrote, our function? How can we use the output of that algorithm to create an algorithm to determine if a given string is an isogram? And then the answer was on the screen, but think about it. If we already have a way to count the number of letters, number of times each letter appears, how can we use that algorithm to check if a word has no repeating letters or numbers?
If you come up with that and you get anything that's more than one, it's not an isogram.
Exactly. Perfect. Exactly right. That's why I wrote here, go through the occurrence algorithm, take the final dictionary, and check if any of the values are greater than 1. So we're not going to do an exercise for this one. I'm just going to show it to you. So here's the first one. Is isogram 1? So first thing we do, we just call count occurrences. We've got the occurrences. And now we say, check each one for v and occurrences.values. .values, what do you think .values does? Gives us the values of the dictionary, right? So like here, this is a dictionary with the occurrences, right? The strings are the keys. The numbers are the values. We don't care what the keys are. I don't care what letters were in there. I just want to know if any of them occurred more than once, right? So we go through all of the values of the dictionary. If the value is greater than 1, we return false. And we can do this immediately. As soon as we find a letter that appeared more than once, we know it's not an isogram. Otherwise, if we've gotten all the way through that dictionary, we've then checked every value, right? And we never returned false. So that means that no value was greater than 1, which means that we can return true. So here's tower. I knew that was the example I was going to use. Is isogram S true? Is isogram S true? And then here's like a crazy Python, like code golf way of doing it. Is anyone interested in unpacking this list comprehension / functional programming thing? We can. I'll walk you right through it.
It does the same thing.
It does the same thing.
Return not any.
So it starts with this list comprehension, right? So if I call that list comprehension, what is it saying? Remember, every list comprehension can be rewritten as a for loop, right? So for x in count occurrences string values, well, actually, that looks a lot like this, right? Except that there's an intermediate variable here. Occurrences equals count occurrences, blah, blah, blah. But here I just called it directly, count the occurrences, and then take the values, right? And I'm saying x greater than 1, that's the piece of data that I'm going to put in the list for every x in that iterable, right? So this is an expression, x greater than 1. What does this evaluate to? True or false, yes. It's a Boolean expression and it evaluates to true or false. So that means I'm either putting true or false in this new list for every value in the count occurrences dictionary, which is for every character in the string, right? So if I do LC S, false, 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 false. Then I say any. Any is a Python functional programming built-in that allows you to check an iterable to see if any of the values are true. That's all it is. So if I do like any false, and it's not just truthy too, right? False, 0, empty list, true, false, empty dictionary. It returns true, right? Because there's one truthy value, at least one truthy value in this thing. If I change this to 0 or false, now it says false. Are any of these true? Nope, none of them are true. And I put in like 100, that's a truthy value. So now it's like, are any of these true? Yeah, 100 is truthy. That's what Python tells us. Great. So it's a built-in function in Python. It takes an iterable, which means what do you think would happen if I did any happy birthday? Would it return? You got two options. It either returns true or false. So you got a 50-50 chance.
It would return true because something is in there.
Exactly. It returns true. Very nice. Okay, so now that's what the list comprehension does. That's what any does. So now I'm saying, are any of these values true? Do any of the letters have a count greater than 1? And if they do, I want to return the opposite of that, not. Because if there is one greater than 1, that means it's not an isogram. If there's nothing greater than 1, it means it is an isogram. So this is our Python one-liner crazy way of doing this.
Is that common to do one-liners like this?
People will do it. If you start reading Python code, you'll see stuff like this. Especially people think that oh, I just need to write this function once. I'm never really going to change it. It's easier if it just shows up on one line and I just forget about it. That's why they would write something like this. This is a lot easier to read. And if you're going to end up changing it a lot or oh, I'm going to use a different function to count the occurrences. Oh, I'm going to pass this from a database instead of blah, blah, blah. That's when you start thinking, maybe I should break it out into the verbose version, because if I need to go back in and understand it, it's going to be easier to understand in is isogram 1.
So,
even if I'm looking at this, I don't even immediately understand what's going on here. I have to stop and say okay, wait, 4x in what? Oh, for this thing, what is this? Okay, but you know what I mean? So. No. They're probably, I don't know, which one would be faster? Actually, I think this one's faster, because as soon as you find something greater than 1, you just return false. Whereas this calculates x greater than 1 for everything in the dictionary no matter what. It goes through the whole dictionary. So to whip out some computer science on you, this is O of n, and this is O of n divided by 2. Which are both O of n, so it doesn't matter. Yeah. Okay, so then, okay, what else? Oh, notice that, and I did want to, it's not just that this is some crazy, weird way of doing it, because remember I was talking about how, there are multiple ways of implementing the same algorithm, right? So here we see 2 ways of implementing the same algorithm, and they're both correct. Both functions that I defined here called the count occurrences function, because as I said in my algorithm, go through the steps of the occurrence counting algorithm. And this is actually, if you do end up studying this computer science, you'll come to the realization that a lot of the algorithms course, they talk about this. First sort the list. Whereas at the beginning of the course, you were learning how to use the sorting algorithm. Then they just say first sort the list. You already know how to do that. You know what I mean? So that's kind of the idea of what I'm showing you here. So then blah, blah, blah. Oh, and here's another possibility. Is isogram 3. Here we're assuming that we don't have the count occurrences algorithm. Oh, we don't have the count occurrences method or function. We haven't implemented it yet. So I can just do the occurrences counting directly in the isIsogram3 function. Basically, I just do that whole algorithm that was there, and then this is the same as before, occurrences.values, right? Like up here, occurrences.values. It's almost like copy and pasting in the other function right in here, basically, you know? So if you are coding the isogram thing from scratch and you don't already have count occurrences, you can just like put it in the same function. That's fine. You could what we call refactor it and like pull that bit of logic into its own function. You know, you got a lot of options. And this is true. While loops. Oh my god. Who knows what a while loop is? Do whiles, something like that. Yeah, while loop. Okay. I'm gonna breeze through while. Well, let's see what else we have in here. Oh, sum of digits. That's a cool one. These are good. These are good. There's some good exercises. I'm gonna break these exercises out when we have like free time some other time. Let's just talk about while loops really quickly. So we have the for loop. We've already seen a million times. There's also this while loop. So a while loop continues executing the code in the loop over and over as long as the condition evaluates to true. So like an if statement, if the condition is true, it does the code, and it does it once. A while loop, as it keeps going to the top and evaluating that condition over and over again, and as long as that condition is true, while it is true, it continues to run the code from the top to the bottom over and over again. So here I have an empty string. I say, while the length of the string is less than 30, append hello to it. So it'll start here. Is the length of the string less than 30? Yes, it's 0, right? All right, append hello. Is the length of the string less than 30? Yes, append hello. Blah, 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 like a few more times, right? I didn't even do the math, like 7, 8 times maybe. And then when we print x at the end, we've got 5 hellos. Oh, because of the space too. Pretty basic example of a while loop. Is there any questions on this? No? Okay. So the most important thing to remember about a while loop, here's my classic, Hazel, I think you said like, you like it when I say the most important thing. The most important thing to remember about a while loop is that you have to update the data that leads to it ending. Okay? So here, I'm saying index equals 0. While the index is less than the length of stuff, print the thing at that index, right? But here's the problem. I never increased the index. So it's going to say, is the index less than stuff? Yeah, the index is 0. Then print it. Is the index less than stuff? Yeah, the index is 0. Then print it. Is the index less than stuff? Blah, 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 forever. It's an infinite loop. So I run it. It just prints 3 a gazillion times. And then I have to stop it. And it's still running. It will run as long as my computer has battery. Takes a glance at its battery level. I'm pretty good on battery, so it will be running for a while. Okay, on the other hand, so while loops are often used for like retrying or redoing work over and over until you hit a success condition. So in this example, we're creating an infinite loop on purpose, but when our condition is met, we break to end the loop. Break is the same keyword as in for loops, and it's used in the same way. It's like just exits the loop immediately, right? So here I'm saying, I've got this getRandomNumber function. It gets me a random number from 1 to 10. I think that's inclusive. It prints the random number, and then it returns it, right? Very simple function. I'm saying while true. So this while loop will never end on its own because the condition is always true. So whenever it gets to the end of the loop, it's just going to say, okay, back to the top, true, okay, keep going, you know? So I intentionally made an infinite loop. But I have a break here. So I'm saying get the random number, and if it equals 5, break. I should probably just say like, found a 5. So 7635, it found the 5. 1, 2, 8, 2, 7, 5, found the 5, right? Does this make sense? Oh, this time it took a while. Whoa, holy crap. Now, I really want to see. 30, it found it on the 36th try. What are the odds of that? At 1 to 10, it'd be 0.1 to the 35th power, 36th power. I'm just saying everyone go buy a scratch ticket because that's crazy. It took 36 chances to pick up the number from 1 to 10. If you're playing roulette, you'd be broke, right? Like, all right. Anyway, and then we just have some exercises that are kind of similar to the ones we did already tonight, but are more involved. And part of these exercises, I'm asking you to define the algorithm yourself. So that's like an extra like thinking step, because in general, like when someone says, "Hey, can you write me a program that does X?" They're not going to give you the algorithm. They're just going to say, "I want it to update my website," and you have to figure out, okay, how do I update their website? First, I have to download the current website. Then I have to blah blah. Like you have to think out the algorithm yourself most of the time. So the exercises in this notebook are largely concerned with you doing that. The remaining exercises, but I am going to stop there for now, for a second, and take questions, and then stop for real. So, are there any questions about algorithms, or dictionary access, or any of the stuff we talked about tonight?
I should have a quick one, like,
Yeah.
what exactly then would be the difference between like function and function and algorithm? Like they're kind of the same.
Yeah. Well, that's a good question. I mean, a function can implement a particular algorithm.
I was only thinking in terms of like the function you had from earlier, like
Count occurrences.
count occurrences, right? So
Yeah.
that is just like a definition.
That's like I was saying. That's like the implementation of the algorithm, right? And so you can just like think about it this way: our isogram function, the isogram 3, this one, like this one is one function that implements one algorithm, which is the isogram, right? Up here, we have is isogram 1. It calls count occurrences, right? So now it's two functions that are implementing one algorithm, the isogram algorithm, right? And then now, if we go further, I have like, well, not anywhere here, but what am I looking for? Oh, all right, here, I'll put it here. So then here I have like, and then I have this function nonsense, which returns the string foo plus the letter x 24 times. So what algorithm does that implement? And not like no algorithm, right? Like it's not, there's no set of steps that, unless your algorithm is, how do I create a string that is the word foo followed by an x 24 times? Like if that's the algorithm you're implementing, then, well, this is the function for it. But you can just have functions that are just doing things and pushing data around that aren't like implementing algorithms. That was the point I was trying to make. Cool? Any other questions about algorithms or any Python features or syntax you're wondering about? Go ahead.
This is going to be a pretty newbie question just from someone who's super new.
Sure.
You mentioned earlier in the lesson that you can use multiple different algorithms for implementing the same thing. And I'm wondering, in a, like, I don't know, like going back to coding review environment,
But it makes me think, oh heck, there's people of like different skill sets and you can do algorithms different ways. Is that like part of the frustration? Is that people can learn how to do their algorithms to get it to work, but then it becomes unreadable versus like
Yeah,
it's
so
readable, but it's too much code, and then like finding a happy balance, or what's the more common mistake, I guess?
well, so you're correct in that there can be multiple algorithms to solve the same problem, right? Like if I want, like here's the problem. I want to get out the front door of Noisebridge, right? So the algorithm is step off the stage, take a right, and walk out the front door, right? But another algorithm is step off the stage, take a left, go up the stairs, cross the building, go down the stairs, and go out the front door, right? Those are two algorithms. They both get me out the front door. So they're both correct, right? But in computer science, that's why I was talking about this big O thing. We talk about like space and time complexity of algorithms. Like obviously going left and going all the way around is kind of dumb because it takes way more steps, right? So it's more expensive, you could say, right? So if we're doing a code review and I said, okay, Hazel, here's my algorithm. I'm going to take a left. I'm going to go upstairs, blah, blah, blah. You might say in the code review, hey, T-Money, this algorithm isn't the best because you're going all the way around the building, but you could just go to the right and go out the front door. You might say that in the code review, right? And then I would have to go back and be like, oh yeah, you're right. Crap, why was I taking a left? Yeah, I should take a right. Oh, this is so much better. And together we solved it a better way. So, but I think that, yeah, so just like you have multiple functions implementing an algorithm, you have multiple different ways to implement the same algorithm, you also have multiple different algorithms that solve the same problem. So I should add that to the notes because I think that's important.
I think that's a perfect answer. Thank you. And
Yeah.
the final mini question is like, let's say I'm on a team like doing some, like open source project for passion, or I'm like at work, and I know that algorithms solve my problem, but I don't know which specific algorithm there is. Is there something that you would lean towards, like whether it's like Copilot or I don't want to say like Stack Overflow, but is there like something people go to when they're like, I know an algorithm solves this, I don't know what algorithm it is? Other than just going like, dang, that's tough.
Yeah. So, I mean, that's just like, in general, you're asking like, how do I solve problems in general, right? Like,
there was someone who's like, well, I didn't know this problem, bro, and it's like, okay, well, what did you do? What are some of the first answers you would expect for them to be like efficient with their time rather than just like, and then like 2 weeks later, like a lot of time later, it gets solved?
yeah, I mean, it's kind of, you almost say it's like the value of a good mentor to like guide you in the right direction. It's also like they talk about, have you ever seen like the forum posts for like how to ask?
Yeah.
So it's like, how do you ask someone to help you with your problem? Like, if you could go up to someone and just be like, it's not working. It's like, what's not working? What do you mean by working? What's the problem? You know? But like a concise description of the bigger picture of the problem and the steps you've already tried, that can help someone help you get on the right track.
Right on.
So it's like, it's also like, if you say like, sometimes people will ask on, like, even like on Stack Overflow, someone will ask like, how do you concatenate a string in Python? And someone will answer. And they're like, well, that doesn't help me. I still need to make my HTTP request. It's like, well, then don't ask the tiny little syntax question you have. Ask the larger problem. What are you actually trying to do, you know? So that's my other advice on that.
And can you just go over that monster line we had earlier?
Oh, the Annie thing? This one? It's in the notebook. Yeah, it's in the notebook, right? Algorithms part 1. Is it not?
I don't think I have it.
Let me see.
Maybe mine's an earlier version or something.
Yeah, did you click the link? Sometimes if you don't click the link to get into the lesson, it might give you an old version. So I have all these versions of everything. Oh, that's weird. It's not in my version either. Yeah, I don't know. I wonder what. Let me see. Is it on GitHub?
Because I feel like I've never seen that before. That one.
It's here. It's on GitHub at least. I don't know. Maybe your thing didn't sync or something. Because it's on GitHub. It's in the latest version of the repo. But like the Python lab can be weird sometimes with syncing to GitHub. You know, if once we start repeating lessons, if I update them, they don't always update. It's annoying, but it's still pretty good for what it is. So, all right, that's it for tonight. Oh, I was supposed to say something. Yeah, no. Besides the thing that I always say, but there's no class next Monday, May 12th. No class. It's already updated on the wiki. I've announced it in the Discord, and I've canceled it on Meetup. So hopefully no one comes. But that's that. All right, and now the part that I love to say. This class is free. I'm a volunteer. I do not get paid. But Noisebridge runs on donations. So if you found anything helpful or interesting in this class tonight, please consider giving a donation. You can do so on the website or using any of the QR codes posted around the space. Thank you.